Chapter 1. Why Rust? This chapter covers the tooling that comes bundled with a standard Rust installation, a first glimpse of the Rust compiler and what makes it so unique, what is needed to write web services in Rust, features that support the maintainability of Rust applications. Rust is a systems programming language. Unlike an interpreted language like JavaScript or Ruby, Rust has a compiler like Go, C, or Swift. It combines running with no overhead, like active garbage collection in Go or a virtual machine like Java, but offers easy-to-read syntax from Python and Ruby. Rust therefore performs as languages like C. This is all possible because of the compiler that safeguards any type errors and makes sure to eliminate many classical runtime errors, such as use after free, before you run your application. Rust offers performance. It has no runtime nor garbage collection. Safety. The compiler makes sure everything is memory safe, even in asynchronous environments. And productivity. Its built-in tooling around testing, documentation, and the package manager makes it a breeze to build and maintain. You might have heard about Rust, but after trying to go through the tutorials, the language seemed too complex, and you gave up learning it. However, Rust comes up as the most loved programming language on the yearly Stack Overflow surveys, and has found a large following in corporations like Facebook, Google, Apple, and Microsoft. This book will unblock you and show you how to become comfortable with the basics of Rust and how to build and ship solid web services with it. Note: this book assumes you have written a few small Rust applications and are familiar with the general concepts of a web service. We will go through all the basic Rust language features and how to use them in this book, but more as a refresher than as a deep learning experience. If you have read through Chapter 6 of The Rust Programming Language by Steve Klabnik and Carol Nichols, see this link. For example, you are fine and won't face any trouble following along with the exercises presented in this book. The book covers Rust 2021 and is backward compatible with version 2018. For you as a developer, Rust provides a unique chance to broaden your horizons. You might be a front-end developer who wants to get into back-end development, or a Java developer who wants to learn a new language. Rust is so versatile that learning it can expand the kinds of systems on which you are able to work. You can use Rust wherever you can use C++ or C, but also in a situation where you would use Node.js, Java, or Ruby. It is even beginning to find a foothold in the machine learning ecosystem where Python has dominated for years. In addition, Rust is great for compiling to WebAssembly, webassembly.org, and many modern blockchain implementations, Cosmos, Polkadot, are written in Rust. The longer you spend writing code and the more programming languages you learn, the more you realize that the most important things are the concepts you learn and using the programming language best suited to the problem. This book, therefore, does not stop at just showing you which lines of Rust code enable you to make HTTP requests. It describes how web services work in general, as well as the underlying concepts behind asynchronous Rust, so that you can pick the transmission control protocol, TCP, abstraction that works best for you. Section 1.1, Batteries Included, Rust's Tooling. Rust comes with the right amount of tooling to make starting, maintaining, and building applications straightforward. Figure 1.1 gives you an overview of the most important tools you need to get started writing Rust applications. You can download RustUp and install Rust by executing the command on the terminal shown in Listing 1.1. This works on Mac OS via brew install rustup-init, and Linux. For an up-to-date way to install Rust on Windows, follow the instructions on the Rust website at this link. The command line tool curl is built to transfer data with URLs. You can fetch remote files and download them onto your computer. The option --proto enables the use of protocols like Hypertext Transfer Protocol Secure, HTTPS, which we use. With the parameter --TLSV 1.2, we use Transport Layer Security, see this link, in version 1.2. Next comes the URL, which, if we open it via the browser, offers a shell script to download. This shell script is getting piped, via the vertical bar, to the sh command line tool, which executes it. This shell script will also install the tool RustUp, which lets you update Rust and install helper components. Updating Rust is as easy as running the command RustUp update. And if you want to install more components, like the code formatter mentioned in Figure 1.1, you use RustUp as well. Running this tool via Cargo FMT will check your code against a style guide and formats the code accordingly for you. You have to specify the folder or file you want to run it for. You can, for example, navigate to the root folder of your project and run cargo fmt dot with a dot to run it for all directories and files. After executing the curl command in listing 1.1, we not only have the Rust library installed, but also the package manager Cargo. This will let us create and run Rust projects. With this in mind, let's create and execute our first Rust program. The following listing shows how to run a Rust application. The command cargo run will execute rustc, compile the code, and run the produced binary.
PHP, what the hell now, bro? Why is it looking up PHP? Fucking. Oh, this is an old project. Nah. How do I get rid of it? Delete. What, dude? PHP Storm? This is not. That's not what I wanted to do. God, fucking PHP pisses me off. Pick this because I thought it'd be easier. Of course, it's fucking complicated. I'm so sick of fucking JetBrains. You can never get this shit off your machine for good. Fucking A, dude. Fucking A. Fuck it. Let's do it here. My cat just scared the balls off of me. I scared him too. Scared each other.
Our new program prints Hello World to the console, and we see shortly why. Looking inside our project folder, Hello, we see the files and folders listed in listing 1.4. The command cargo new creates a new folder with the name we specify, and also initializes a new Git structure for it.
So far, so good. It says you need to know Rust. I definitely do not. But it said it was a good beginner book, so what the fuck? And then the first paragraph, it's like, we assume you've written Rust applications before. Okay, well, fuck me then. But so far, so good. I had a different book from Manning that we started yesterday, and then, I don't know, I got a fucking refund because I told them I wanted a refund for the PDF. I wanted to keep the live audio. They end up refunding the audio. I'm like, dude, what? It doesn't matter. They're good folks.
The
Obviously,
command cargo run
brought
will
them more
build the
business
application
anyway.
and execute the binary, which lives inside the ./target/debug folder. Our source code lives in the src folder. Depending on the type of application we are building, this folder has either a main.rs or lib.rs file in it with the following content.
The command cargo run will. Okay, yeah, I saw that part.
In Chapter 5, you will see the difference between the lib.rs and main.rs files, and when cargo creates which one. The folder target contains another folder called debug, which contains our compiled code, generated by the cargo run command. A simple cargo build would have had the same effect, but would just build and not execute our program. When building a Rust program, the Rust compiler, rustc, is creating Rust bytecode and passes it on to another compiler called LLVM, llvm.org, to create machine code. LLVM is also used by languages like Swift and Scala and turns bytecode produced by the language compiler into machine code for the operating system to run. This means Rust can be compiled on whatever operating system LLVM supports. The whole stack is shown in Figure 1.2.
Oh, sweet. Okay. Get out of the way. Copy. Okay, parsing. Baby. LLVM. Compiler flow. Where's the rest of it? Ah. Was that it? Oh, it was. Okay, my bad. Alright, after installing. Okay. Oops. Dude, what is it doing? This is the JetBrains free dedicated Rust IDE, so I want to try it out, but the fuck's taking so long? I'm using WSL, and yeah, I don't know why it's taking so long. It's fucking bitch ass PHP. Man, I wish I wasted so much time barking up that tree. Fucking sucks, dude. Laravel my ass. Seriously, like, it sounds weird, but I never even considered it. But you literally, you're deploying fucking text files out to your server. Like, that's nuts. That's fucking crazy. What? Fucking Stone Age shit? No, that's crazy. I mean, I guess I knew that, but once I finally approached it, because, you see all the bells and whistles, and then you realize why there's so many bells and whistles. It's like, you fucking need an army to deploy that shit. Or you can just go fucking pay Taylor Altwell, use Forge, right? Yeah, just use Forge. Fuck off. Deploying fucking just wide open source code. You can just hit the server. That's crazy to me. That's nuts to me. The web is one thing. I mean, that's ain't nothing you can do about it. But PHP, you're making like a concerted effort and decision to use this like ancient tech. I don't give a shit if they added types. No, man. I burned a lot of time on that. Really has very little to do with the language, although that's not my favorite either. It's object oriented. I don't want to use classes. So it was just not a good fit. I'm not going to say it's not going to work for anybody. You can throw up a website quickly. Yeah, cool. Great. But yeah, deploying that is a fucking nightmare. And eventually, I'm learning this because I'm like 6 months out from a project for work, but it's going to be for enterprise in the Microsoft Fabric space. So I can't fucking throw out just open source files. That's ridiculous. You get laughed out of the fucking room, brother. I don't think this thing's gonna fucking finish. They make it so fucking complicated. I just fucking forget it. Just
Figure
use.
1.2. After installing RustUp, you have the Rust standard library on your machine, which includes the Rust compiler.
Uh huh. I do. Let's connect to my box here. Wow. Dev desktop. We'll just start here to see what happens.
Another important file is cargo.toml. As we see in listing 1.6, it contains the overall information about our project and specifies the third-party dependencies if necessary. Note: when developing libraries, the cargo.lock file should not get checked into your version control system, like Git. But when creating an application, binary, you should add the file to your version control system. Applications, binaries, are often dependent on specific versions of an external library, and therefore other developers you are working with need to know which versions are safe to install or have to be updated to. Libraries, on the other hand, should function on the latest version of used libraries.
Okay. .10 2021. No dependencies. What is this? Oh, it's just a comment. Okay.
Installing third-party libraries happens by adding the names of the dependencies under the Dependencies section and running cargo run or cargo build. This will fetch the libraries, called crates in the Rust community, from crates.io, the Rust package registry. The actual fetched version of the installed packages appears in a new file called cargo.lock. If the file is in the root folder of your project, Cargo will fetch exactly the version of the packages specified in the cargo.lock file. This will help developers working on the same codebase to replicate the exact same state across different machines. TOML file. The TOML file format is like JavaScript Object Notation, JSON, or YAML ain't markup language, YAML, a configuration file format. It means Tom's obvious minimal language, and as the name suggests, should make configurations easy to read and parse. The package manager Cargo uses this file to install dependencies and populate information about the project. To quote one of the Rust core members, "It is the least terrible option." See this link. This doesn't mean that TOML is bad, but just that there are always trade-offs when handling configuration files. The last tool in our belt is the official code linter Clippy. This tool is included now by default when installing Rust. It can also be installed manually if you operate on older Rust versions.
Clippy. I didn't know about that. Let me make sure I got it. Add Clippy. All right.
Chapter 5 introduces the use of Clippy and details how to configure it. Section 1.2, the Rust compiler. The advantages of using Rust versus other languages is its compiler. Rust compiles down to binary code with no garbage collection invoked at runtime. This gives you C-like speed. In contrast to C, however, the Rust compiler enforces memory safety at compile time. Figure 1.3 shows the differences between popular programming languages used for server-side programming and C.
The advantages of Rust versus other is its compiler. Oh yeah, I was just looking at this graphic. Yep. Straight up, brother. Here. And you, and you. Compiler. Get your compiler to do it only you. La la la. They gotta let me add those quicker. Okay.
Each language has trade-offs. Go is the newest of the demonstrated languages and comes closest to the speed of C. It uses a runtime for garbage collection
No, it doesn't.
and therefore operates with a bit more overhead than Rust does. Go's compiler is faster than Rust's C. Go aims for simplicity and takes a
Way
small
fucking
runtime
faster.
performance hit to do so. You see that Rust offers no runtime overhead, and because of the compiler, offers more comfort and safety while writing code.
I just say this about Go because I wrote 2 small ETL programs in Go doing the whole, AWS fuck shit. There's nothing, I think most people would not encounter anything where, like, fucking Docker's written in Go. CockroachDB's written in Go. I don't think it's a performance thing. But what I can tell you is the reason I'm here now with Rust, it's not really about the safety even, although that's obviously better. Go's syntax fucking sucks, bro. It's the ergonomics of it. So, yeah.
You see that Rust offers no runtime overhead, and because of the compiler, offers more comfort and safety while writing code than Go or JavaScript, for example. Java and JavaScript require a, sort of, virtual machine for running the code. This results in a heavy performance penalty. One of the adjustments you will have to make when writing programs in Rust is to work with the Rust compiler to build applications. When you come from a scripting language, this is a huge shift in mindset. Instead of starting an application in a few seconds and debugging it until it fails, the Rust compiler will make sure everything works fine before it starts. For example, consider this code snippet from later in the book, just printed here for demo purposes.
Match ID.is empty. No arguments. False. Return okay. Question ID to string. True. Return error. Okay, I don't know. Yeah.
If you cannot read this code snippet yet, don't worry. You will soon. That's a match block, and the compiler makes sure we cover every use case, whether ID is empty or not. If we delete the line with true goes to and try to compile our code, we will get an error.
That's a match block, and the compiler makes sure we cover every use case, whether ID is empty or not. If we delete the line with true and try to compile, we will get an error. Match ID is empty, pattern true, not covered. Oh, okay. I see what they mean. Well, great, brother. Get to it. All right, where were we? Shoot. Skip down here.
Listing 1.8.
Not that one.
The compiler highlights the line and the exact position in our statement, and in addition gives a suggestion for solving the issue at hand. It is designed to produce error messages that are understandable and readable by humans, rather than just exposing the internal parser error. First, making sure the program operates correctly in all use cases might seem tedious in small applications, but once you have to maintain larger systems and add or remove features, you will quickly see how writing Rust can sometimes feel like you are cheating, since so many issues you had to think about in the past will now be covered by the compiler. It is therefore seldom that you will be able to run newly written Rust code right away. The compiler will be part of your daily routine and help you understand where to improve your code and what you might have forgotten to cover. You can't jump quickly into Rust as you can, for example, into JavaScript or even Go. You need to become familiar with a set of basic concepts first. In addition, you must learn many aspects of Rust to become a proficient Rust developer. That said, you do not need to know everything to get started. You can learn as you go with the help of the compiler. You see, the Rust compiler is one of the strongest arguments for using Rust. Once you've become proficient, you can use Rust in multiple areas: game development, back-end servers, machine learning, and maybe soon Linux kernel development. This is currently an ongoing discussion and trial phase. See this link. If you develop applications in a larger team, it helps to know that newly trained Rust programmers must pass through the compiler first before they can contribute to the codebase. This will already cover a huge amount of code review and guarantees a baseline of code quality. Section 1.3, Rust for Web Services. We covered the main reasons we might choose Rust over other programming languages. Let's look at how we can start writing web services with it. Surprisingly, Rust doesn't cover as much ground when it comes to HTTP as, for example, Go or Node.js. Since Rust is a systems programming language, the Rust community decided to leave efforts around implementing HTTP and other features to the community. Figure 1.4 shows a typical tech stack of a web service and to which degree Rust offers help. The bottom two layers, TCP/IP, are covered by the Rust stack. The Rust standard library implements TCP, and we can open a TCP, or User Datagram Protocol UDP, socket and listen for incoming messages.
Interesting, brother. Copy. I wish they would start bigger. That's what she said. Right here. There you go. STD.
However, there is no HTTP implementation. Therefore, if you want to write a pure HTTP server, you have to either implement it from scratch or use one of the third-party libraries, like Hyper, which is used by curl behind the scenes. When using a web framework, the choice is already made for you. The web framework ActixWeb, for example, uses its own HTTP server implementation, Actix-server. When you use Warp, Axum, or Rocket, they all use Hyper as a web server, opening a socket, waiting for, and parsing HTTP messages. We can see in Figure 1.4 that TCP is included in the Rust standard library, but everything above that is enabled by the community. But what does this look like in code? Let's take an example from Go. The following listing shows an HTTP server written with Go.
Yep, looks familiar. Package main. Imports. I also hated this. It's a small gripe, but why do I gotta put these in fucking quotes? You know what's in here. Shit. This bullshit. Old school, bro. I mean, I get it, but come on. Fucking that /s. The string interpolation too is pretty crotchety, gotta say. I will miss those buttery, fast
We can see
compile
that
times,
Go
though.
provides us with an HTTP package. Rust is missing the HTTP part, and it stops at implementing TCP. We can use Rust to create a TCP server, as shown in the following listing, but we cannot use it right away to respond with formal HTTP messages.
Wait, I can put that in here? Wow. Unused variable stream. Main RS. Line 3, 18th character. Dang. Now, I saw errors like this in books and tutorials and whatnot. I'm like, man, that would be quite nice, even if the language is a challenge. Look at this. It's not like I'm in a rush anyway. The terminal process, what all is it telling me here? So it tells me where to find it. Literally points to the problem. That's awesome. Nice and formatted, not some fucking blob like Node. Fuck you, Node. Seriously. Rust in action, finish, running, error, code 13, kind permission denied. Cargo run. Okay.
Therefore, it is up to the community to implement HTTP. Luckily, plenty of implementations are out there already. And when choosing a web framework later in the book, you don't need to worry about that part of the stack anymore. Another big cornerstone of writing web services is asynchronous programming. This gives us the ability to handle multiple requests at once, and it reduces the wait time for responses from the server. When a web server receives a request, some work has to be done, accessing a database, writing files, and so forth. If a second request comes in before the work is finished, that request would have to wait for the first one. Imagine millions of requests coming in at almost the same time. Therefore, we need a way to somehow put work in the background and continue accepting requests on our server. This is where asynchronous programming comes in. Other frameworks and languages, like Node.js and Go, do this to some degree automatically in the background for us. With Rust, we have to understand the building blocks of asynchronous programming a bit more granularly to know which frameworks to choose. A programming language, or the ecosystem around it, has to offer the following concepts so we can create applications that can process work asynchronously. Syntax marks a piece of code as asynchronous. Type, a more complex type that can keep the state of the asynchronous progress. Thread scheduler, runtime, a way to handle threading or other methods to put work in the background and make progress on it. Kernel abstractions, use the asynchronous kernel methods in the background. Asynchronous runtimes in Rust. When we talk about the runtime here, it is not the same as a Java runtime or Go garbage collection. During compilation, the runtime will be compiled into static code. Each library or framework that facilitates some form of asynchronous code will choose a runtime to build on top of. The work of the runtime is to choose its own way of handling threads and managing work, tasks, behind the scenes. Therefore, it is possible to end up with multiple runtimes. If you choose a web framework that dictates the Tokio runtime, for example, and has a helper library to do asynchronous HTTP requests, which is built on top of another runtime, then you basically have two runtimes compiled in your binary. Whether or not you run into side effects depends on the design of your application. What does this look like in Rust? Let's look at listing 1.12 to see how asynchronous fetching of a website looks in Rust. This code can be found in the book's GitHub repository at this link. We don't go into detail here. This is left for Chapter 2 and onward, but this should give you a first idea what asynchronous code looks like in Rust.
Hold on, let's get that pulled down here. Na na na. In. Oh, wrong file. Git clone. Oh. What? I literally just fucking cloned it. I'm so confused. Don't save that. Okay, there we go.
What does this look like in Rust? Let's look at listing 1.12 to see how asynchronous fetching of a website looks in Rust. This code can be found in the book's GitHub repository at this link. We don't go into detail here. This is left for Chapter 2 and onward, but this should give you a first idea what asynchronous code looks like in Rust. For this snippet to work, you need to add the external crate request, which is not a typo and we don't mean the word request here, to your project via the cargo.toml file.
Oh. Use std. So these are the accessors. So that's like one thing that's immediately different. Kind of looks like PHP, but they use that instead of dot notation. Rust uses like this is like a namespace accessor, not a method. Yeah, I don't know what you call that. Method accessor? I don't know. But like for method calls, that they still use dot notation. PHP uses this for their method calls, but whatever. I'll get used to it. I think Elixir did this too. But yeah, so this is the namespace accessor. So standard, library, collections, hash map. I don't know what that means yet. Or I don't know why it's here. I guess I should say Tokyo main. Okay, async f in main. I love this f in. That's perfect. It's the little things, f and main. So we still got this notion of the main function, which is cool. That's fine. It's not a biggie. Swift doesn't make you do that, but I kind of prefer it just because you at least know like where the fuck you are in the program. You don't have to depend on the file name necessarily. So return arrow, at least it's not a fat arrow. Results. I assume the pokies are for like generics, maybe. I don't know. That's what it was in Swift. Din, dynamic, standard error, I don't know. Let rest equal request, which is the library. Request, this would be the dot, so. Or maybe they do this. I guess we'll find out. But get this target await. If it's like Swift, that's like to handle nulls. I like this chaining though. Await JSON to a hash map to a string. What is that, brother? Another await Oh, so I guess that's JSON. Wait again? Huh. I don't know why that's there. A print line. Man, this looks fancy. And I can read like 2 lines of it.
We annotate the main function with hash of Tokyo : main. Tokyo is the asynchronous runtime, or thread.
Oh, wait. We annotate the main function with Tokyo main. Oh, I didn't add the thing to my TOML. I guess.
We annotate the main function with hash of Tokyo : main. Tokyo is the asynchronous runtime, or thread scheduler, we are using here. Tokyo itself is using, through another crate called Mio, the asynchronous kernel application programming interface, API, from the operating system we listed earlier. We can mark a function as async with the standard Rust syntax.
That was a mouthful. What? Okay, so
We annotate the main function with hash of Tokyo : main. Tokyo is the asynchronous runtime, or thread scheduler, we are using here. Tokyo itself is using, through another crate called Mio.
oh, okay. Let me grab a picture of the. And here, hiya, hua, ha, hua. Oops. I told myself I would take better notes this time. So here's an example thread scheduler. I paid good money for this fucking Appcast, whatever, infinite storage, sharing comments, and never fucking use it, bro. So we're gonna get some mileage out of that. God damn it.
When we talk about the runtime here, it is not the same as a Java.
Oh, that's not. We were further. I was. Oh, yeah, it's here.
We annotate the main function with hash of Tokyo : main. Tokyo is the asynchronous runtime, or thread scheduler, we are using here. Tokyo itself is using, through another crate called Mio, the asynchronous kernel application programming interface, API, from the operating system we listed earlier. We can mark a function as async with the standard Rust syntax, and await on a future, see this link, type. A future in Rust is a trait which can be implemented onto types. This trait dictates that the implementation must have a type output, indicating what the future returns when the computation is complete, and a function called poll, which a runtime can call to do work on the future. When working with web frameworks, you might never touch the actual implementation of a future, but it is important to understand the underlying concept, so compiler messages and framework implementations make sense to you.
Okay.
We can mark a function as async with the standard Rust syntax, and await on a future, see this link, type. A future in Rust.
Oh, okay, so let's go check it. Trait std future. Public trait. Type output. The type of value produced on completion. Okay. Required method. Oh, hold on. Are these, oh, I hope they are, because then that'll make it a lot simpler for me. Hi, Claude. Are Rust traits like Swift protocols. Yeah, baby. Dude, yes. I fucking know Rust. Well, yeah, part of it. Woo, yeah, Rust traits and Swift protocols are quite similar. Both are ways of defining shared behavior that types can implement. Yeah, this was probably, aside from like the case statements, my favorite part of Swift. I just thought it's so fucking cool because I mean, lots of systems tell you that you can share behavior, blah, blah, blah. That was the promise of classes or whatever. But yeah, I like this a lot. This is really good. Yeah, Rust trait, drawable. So anything you list inside a trait, you can then use, well, you can combine them, but you can use a protocol in the same position as you would a type. And it will enforce the requirements. So if you define a trait as drawable and you say function draw with the argument self, then anything that you assign drawable to would also have to implement a function called draw with self as the argument. Beautiful. All right, I guess that's what that is. Yeah, okay. I guess it's yeah, because in Swift you didn't. I mean, there's just nothing there, but maybe that's implied, and Rust is more granular, so it's actually requires you to type that out. I don't know. But then that would, I don't know, whatever. I'm not going to try to guess. But okay, so this makes good sense to me then. So yeah, I mean, minimally, it's an enforcement of some kind of shape or requirement that a function exists or a property exists within a thing without having to. It's like well, I guess that's the best way I can describe it. Enforcing something, not inheriting something. There were some gotchas in that around Swift. Like you couldn't guarantee necessarily. I think Swift let you could still have a different output type. It just required that there was a function called draw. It didn't necessarily have to do the same thing, if that makes sense. But the return type would have to still be the same, the output type. But okay, good. So that's exciting. All right, so where was I?
We can mark a function as async with the standard Rust syntax and await on a future, see this link, type. A future in Rust is a trait which can be implemented onto types. This trait dictates that the implementation must have a type output, indicating what the future returns. We can see in figure 1.
Hold on, brother. Shit. Sorry, my bad. Oh, am I saying sorry to you? Fucking, I don't even know who you are. All right, let's see. Where was I though? Damn it. HTTP Actix. I was way down here. Is this even the same book? What the hell? Yeah, mark them as async. Oh, yeah, okay. This is where we were.
In contrast to other languages, in Rust, work by futures is only beginning when handed over to the runtime and actively started. An asynchronous function returns a type of future, and the caller of the function is responsible for passing this future to a runtime to do something with it. For the developer, this means adding .await to the function call, which indicates to the runtime to execute it. There are also other ways of starting futures, like the Tokyo join macro, see this link, which we...
Oh, so this This means adding a weight to the function call. Oh, that's not the caller. Duh. Okay, my bad. That's what the. But I wanted to see this. Is this what we tried to look at the first time? It is, and I didn't because I got sidetracked on protocols. Now I remember macro rules. Join. Future expression. I don't know what the asterisk is. Range. Waits on multiple concurrent branches, returning when all branches complete. Oh, nice. Oh, duh, join, hence join. Okay. Must be used inside of async functions. Inside of them. Inside, on the inside. So if I do no definition. Okay, okay. Well, either way, it makes sense. So the join macro must be used inside of an async function, closures, and blocks. What's a block? The join macro takes a list of async expressions and evaluates them to evaluates them concurrently on the same task. On the same task. Okay. Each async expression evaluates to a future, and the futures from each expression are multiplexed on the current task. God damn, brother. Each async expression evaluates so like these, yeah. This JSON, this print line. What is okay? Fucking Copilot, just to me, is just the worst. So, what the fuck are you supposed to use it for? In Rust, actually, this is what I wanted. In Rust, the OK expression is commonly used to indicate successful completion of a function that returns a result type. Oh, literally just okay. Literally okay. I wonder why though. Why? What are common use cases? Yeah, tell me. Close that up. Can you get up in here, bro? Can I? I thought I could move. Ah, that's better. That's way better. Let me just close him up. Okay, common use cases for OK. Functions performing side effects. Functions that perform actions such as writing to a file, sending a network request, or updating a database often use OK to indicate successful completion without returning a meaningful value. Oh. Well, okay, that does make good sense. Code to write a file, OK. Initialization functions initialize some state or set up resources, but do not. Oh, okay, so like a DB connect, event handlers. Oh yeah, that's a big one. This is I'll be using that. fucking S3 buckets and data lake. Fucking data lake. Hello. Working with some overseas folks, so they're in that they're just getting started. It's weird to think. Fucking JetBrains. Unit test, okay. Oh, that makes sense. These use cases leverage Rust result type to provide robust error handling. What? So, is it required in any of these? Or just good practice? Good practice, but not required. Error handling by returning a result. Functions can leverage Rust's powerful error handling mechanisms. This allows the caller to handle potential errors gracefully using match statements or the ternary. Wait, is that what that is? What is the... What is the ternary one? Is that the... I thought it was that. Maybe that's JavaScript. I don't know. Okay, so the question mark operator in Rust is a shorthand for error handling. Actually, I think that was what Swift did too. When used, it automatically returns an error. Makes you wonder, it doesn't matter, but like, do they get together and kind of just decide on new standards, standards? They probably do. When used, it automatically returns an error from the current function if the expression it is applied to evaluates to an error. If the expression evaluates to OK, it extracts the value inside the OK and continues execution. Here's how it works. Propagation of errors. If the expression evaluates to error, the error operator returns the error from the current function. Okay, that part makes sense. Unwrapping. I guess I unwrapping values. If the expression evaluates to OK, the error operator unwraps the value inside the OK. What is it? What's in there though? What? Oh, you can put anything in there. Oh. OK contents. OK, I guess ignore probably under bar. Wow. Okay, let me think about this, brother. Hold on. So let mutable contents equal create a new string, some kind of string, match file, read to string, borrow the mutable contents. See, I learned that yesterday. The ampersand. That's I think, right? I'm pretty sure that's right. This tells it that you're now borrowing something because it was here, but now it states here now, brother. I'm borrowing. Let me borrow that shit. Borrow here. That's the whoa. Okay, it's a match. They call it an operator. What did they call it? Or an expression. The error. Oh, statement. Okay, yeah. So match file read to string mutable contents, and then I have to indicate the borrow to the borrow checker, and then OK, or if it's OK, wait, what's fat arrow? Okay, now I'm lost. Tell me what this means. In the second example, the Error operator simplifies the code by handling the error propagation automatically, making the function more concise and readable. Oh, without and with. Okay, so I don't necessarily need to. Okay, good. So I don't need to know what fat arrow is. I'm not going to concern myself because I'll just use this operator. So fn read file path. Borrow string. Is that what that is? Is the indicating a borrow? Is that how you say it? Okay, yeah. Borrowing is a concept. Rust ownership system, it allows you to reference data. What I like about it is, and this could be incorrect, I don't know yet, but if you think about it very, like, I think Rust, I think we're going to get along because it seems just very literal, very procedural, like very procedural. But if you just imagine what's happening and you read from the, or you write your code top down, which is very similar because I used to write a ton of SQL, and that's how you do it. I mean, if you're writing a procedure, that's more or less the best way to do it if you need to ensure that things happen, in a very linear fashion. Some people would disagree with that, but it works like that, or it can work like that for you. And it seems like Rust is that way too. So I'm really digging this. At least within like a function body, not necessarily like an entire file is going to be top down, but within a function body, you can think about it encapsulated in that way in terms of like handling state, which I really like that. Okay, enough of GitHub. I forgot, got a whole book over here. But okay, so that was helpful. But I do want to know, I guess I just want to read about OK real quick. It's just I'm. Oh, this is Tokyo. I just have Claude tell me about it. Tell me about. Oops. Claude always said, okay. It's a common idiom in Rust that you'll see a lot. OK is a variant of the result enum. Okay. Yeah, okay, so, okay, good. So that's another, like, Swift parallel, so I can relate it to something. Used for success cases, although it was not a common idiom in Swift 2, I think they're trying to make it that in 6. Empty parentheses is what? Is Rust's unit type, similar to void in other languages? I know what they're talking about, and yeah, that was everywhere in Swift. Yeah, but I still don't. I really don't understand what it's for, honestly. Together, OK means success with no meaningful return value. Oh, hence void. Okay. So you got to return something, but if you don't want to return anything but something. Go. It is commonly used in functions that need to indicate success failure. Okay, so I just need to leave it at that in my brain. Okay, so I need to indicate success. If it's failure, then I'm going to handle it with an error, some kind of graceful message. So I can just think of this as success. A more explicit indicator of success. How about that? Don't forget to return actual data, just success, failure. Oh, don't need to return actual data, just success or failure. Function, do something, return, result, true, false, and an error message. Do some work. OK, returns true. This feels awkward. What does true mean here? The pattern is especially... Why did he, instead of... Oh, okay, my bad. Yeah. Thank you, Claude. Isn't he great? Well, that's very helpful. Okay, it's commonly used in functions that just need to indicate success, failure. So, okay, if it succeeded, otherwise an error instead of this. So you wouldn't do this. That's why he's showing. This feels awkward. And yeah, that doesn't read as well. So, yeah. Okay. So now that makes more sense. Hence, network calls, writing files, blah, blah, blah. Okay. All right. Good on you there, Clodster. And I think I will. Yeah, that's a nice little. Can I tag? Okay, good. I can tag this. Type tag. Rust along. Like that, brother? All right. Rust along. Rust along. Okay. Now this is the Rust Power Hour. How long has it been? I still got to get down on some Halo. And so I'm thinking. Here's what I'm thinking. Well, I guess we'll find out very quickly. But I forget where I saw this. But they say you should stop on a good note, on a high note, while you're having fun, you're learning. So I'm going to cut it off there. I had 3 viewers yesterday and none today on a Monday night. I guess it's slim pickings out there, brother. But hey, it's all good, man. This was fun. I really like Rust. I like Rust, and I like that it's not trying to cut corners. I've been doing too much of that anyway, just broadly speaking. So I think this, generally speaking, is going to be a much better approach across the board. For me, it's a better fit. It's challenging. It's engaging. I think other things like the JavaScript frameworks, there's too much. It's too much shortcuts. You can't fucking. You just can't do it that way. I can't do it that way. I've done the shortcut thing. It's not as fun because you very quickly bump up against that glass ceiling. So anyway, for anybody that picks this up, apologies for the context switch, but we're going to stick with this web development book. And so the promise of this book is that we're going to end up effectively building an API in Rust end to end. So if that is appealing, then drop a sub, drop a nub, and then yeah, we'll see you next time. I'm going to hop onto the Halo stream. Peace, love, and